Now we are doing the last part, which is using the equations to get if something is differentiable or not. Now, how do we do this? Well, how do we do this? We are going to be saying for something to be differentiable, we'll be having this g of x like that, right? So I should show you the two types of problems. For continuity, we saw that. Then for differentiability, I want to show you the two types of problems that you have in your thing, okay? This is not my work, so just know that. Here, I'm going to show you the two types of problems. So first of all, we have this g of x equal to whatever. Now, for something to be differentiable at all values of x, first of all, we are going to get the derivative of x for this one, and we'll get the derivative of x for this one, and then we are going to substitute the point where they meet because we are going to test differentiability at this point. This is the controversial point where the two of them meet. So what you're going to do is you're going to say what it is like is it's just like what you'll be getting is you'll be getting the derivative from first principles where you use the limit. So it's like you're getting the limit, but you get it from the left and then also from the right. It's like you're getting the limit as h goes to 0 of f of x. This is g, right? So g of x plus h over h. That is h goes to 0 from the right, then we do h goes to 0 from the left. That's kind of what it is, okay? So it is g of x plus h minus g of x over h, of course. And you do it from the, so I'll be saying this limit is g of x plus h goes to 0. Actually, this for x will be now putting this value where we are. What is it? It's 0. So it's like g of 0 plus h minus g of x over h as you go to 0 from the right should be equal to the limit as x goes towards 0 from the left of g of, where there is x, we're putting 0, so 0 plus h minus g of x over h. So that is kind of what it is. It's something like this. And if the limits are the same, then we can be able to go to the next thing. So for this one, the other way to do it is we know that this limit is just the derivative. So you can say that it's going to be, you can say the derivative, we have g of x, right? So you can say g prime of 0 should be equal to, you say g prime of 0 when x is less than 0 should be equal to g prime of 0 when x is greater than or equal to 0, okay? So these are the two things. You must put these two conditions together. The one on top is like the one on the bottom. The one on the bottom is easier. So what you're going to see us testing this is the condition we test. So what we're going to do is we're going to differentiate this guy. We say when x is less than 0, we take g of x being this, then we'll find g prime of x. Okay, then after finding g prime of x, we'll find g prime of 0 because we are at this point 0. So we'll find g prime of 0 and it'll be something, it'll be whatever it is. Then we can now do when x is greater than or equal to 0. If x is greater than or equal to 0, we'll now say if x is greater than or equal to 0, you say comma, you now say g of x is equal to this. Then you find g prime of x. After you have g prime of x, you put this point, which is 0, into it, you get g prime of 0. Once you have them, you now write this condition to say for differentiability at x equal to 0. So you're going to say for differentiability at x equal to 0, then you put this. G prime of 0 when x is less than 0 should be equal to g prime of 0 when x is greater than or equal to 0. Now you put the answers you would have gotten and you test. If it's true, then it's fine. That is what you do here for this one. You can find the value of a just using that. Okay, you are going to have the value of a just using that for differentiability. So we can remove this first thing and you can remember this one in the bottom to say the g prime of this when x is less than 0 should be equal to g prime of 0 when x is greater than or equal to 0. Then you'll be having your differentiability. And remember, to get g prime of 0, you need to choose the right. You go if x is greater than 0, and then you choose the right g of x, blah, blah, blah. Okay, that's what you must do. Remember to do that. Now I'm going to go to the one below and see and show you something. Okay, sorry for this. I'm going to go to this one. This one is now harder because they are now two variables, a and b. Now they want a and b. So we still use the same thing to say for differentiability, right? So what you're going to have to do is you're going to say if x is greater than minus 1, then you'll be now saying f of x will be equal to ax plus b, which means f prime of x, you differentiate. What's the derivative of ax? It's like the derivative of 2x is 2. So the derivative of ax is a. The derivative of b is a 0, so this is going to be a. Now, what is f prime of negative 1? Remember, that's the point we are at now. F prime of negative 1, it means we're putting negative 1 wherever there is x, but there is no x here, so it still just comes back as an a. So now you can now say, you skip lines and say, if x is less than or equal to minus 1, you have your f of x, okay, being whatever it's going to be. You have it. And if you have your f of x being that thing, then you will, if x is less than, you would have f of x being equal to this other one, bx squared minus 3. Then you have your f prime of x. Once you have your f, it will lead to f prime of x. Once you have your f prime of x, you have a f prime of minus 1. Once you have your f prime of minus 1, you are going to now say, after you have them, you will now say for differentiability at x equal to minus 1. Okay, that is what you now say. For differentiability, at x equal to minus 1, you now say f of f prime minus 1, if x is greater than minus 1, should be equal to f prime of minus 1 if x is less than or equal to minus 1. So the two derivatives which you got for the two different conditions should be equal, then you're going to get. But guess what? This is going to be one equation and it won't be enough. Now you're going to need to use the second thing to test, to find b as well, because here you're going to find an equation and it will be equation number 1. Now, to get the second one, which will help you, you now have to remember that differentiability, when things are differentiable, they have to be for continuous functions. So that means we will now use the second idea of continuity. The second idea of continuity, we will just use the idea that the limit as x goes to minus 1 from the right is of f of x is going to be equal to the limit as x goes towards minus 1 from the left of f. So you get the limit as x goes towards minus 1 from the right. It means from greater than minus 1, which is x greater than minus 1. So for ax, you get the limit for this one as x approaches minus 1. Then you get the limit for this one as x approaches minus 1. You make them equal and you're going to make your equation number 2. And with it, you're going to use it to solve. So remember, the second one is on limits. Sorry for this. Okay? The second one is for limits as you go towards this point here, minus 1, from the left and from the right. If they're equal, then you'll be fine. Why do we do that? Because we know that differentiable things are continuous. So don't ever forget it. And that is what we're going to use. And you'd be done. And that is it for differentiability. Okay? Goodbye for now. See you in the next.